All right, so we're just going to do some practice first. I'm going to ignore the instructions. I'm just going to do rational zeros theorem on each and every one of these. So we've got rational zeros theorem. So the first one that we're going to do is 2x to the third minus 5x squared minus 4x plus 3. And again, I am not going to follow the instructions. I just want to get you practicing rational zeros theorem. So how do I do rational zeros theorem, and what does it tell me? It's going to tell me pretty numbers to look for using synthetic division if I don't know what the answers are. So take the last number, which is 3, over the first number, which is 2. What numbers can I multiply together to get 3? And what numbers can I multiply together to get 2? And be very, very methodical, otherwise you're going to mess up. So take everything on top over 1, everything on top over 2. So 1 over 1 is 1. 3 over 1 is 3. So I'm done with him. 1 over 2 is a half. And 3 over 2 is 3 halves. So that is rational zeros theorem. So let's just do it a couple more times. I've got x to the third minus 3x squared plus 25x minus 75. So rational zeros theorem says take the last number, which is 75, over the first number, which is 1. So numbers I can multiply together to get a 75 will be a 1 and a 75, not a 2, a 3 and 25, not a 4, a 5, and holy cow, what is that? 15. And then that's it. So rational zeros theorem, since it's just over 1, that's pretty much it. So if we were looking for zeros and this were not factorable, I would try numbers that were in here. 2 is not in this pile, so I wouldn't try 2. 4 is not in this pile. I wouldn't try 4. It's not going to work. If it's going to cross in a pretty place, it will be in this pile. So let's just do 1 or 2 more, and then we'll get on to the others. So we've got 2x to the fourth. Hang on, I just did one like that. Just a minute now. All right, I've got 4x to the fourth minus 16x to the third plus 83x squared minus 4x minus 21. And I want to do rational zeros theorem. So take the last number, which is 21, over the first number, which is 4. Numbers I can multiply together to get 21 are going to be 1 and 21 and 3 and 7. And numbers to get a 4 are going to be 1 and 4 and 2. So my list, again, be very methodical. So take everything on top over 1. So 1 over 1 is 1. 3 over 1 is 3. 7 over 1, 21 over 1. So he's done. 1 over 2 is a half. 3 over 2 is 3 halves. 7 over 2 is 7 halves. And 21 over 2 is 21 halves. So he's done. 1 over 4 is a fourth. 3 over 4 is 3/4. 7 over 4 is 7/4. And 21 over 4 is 21/4. So that's a nasty list, but at least it gives you a guideline to go by. All right, so let's actually backtrack. And what we're going to do is go ahead and do these from start to finish. So I'm going to wait on Descartes' rule of signs, and I'm just going to do a few of these. So this one says, hang on. It says use rational zeros theorem to list all of your potential zeros. I don't know if these are answers or not. So I have a 2x to the third minus a 5x squared minus a 4x plus 3. And we just did rational zeros theorem a while ago on this one. So what is my answer? Numbers that multiply together for 3 over numbers that multiply together for 2 will give me 1 and 3 and 1 and 2. So the numbers that I'm going to try are going to be 1, 3, a half, and 3 halves. Now, if this was factorable, I could just factor it and be done. But it's not factorable. So I'm going to have to find some answer first. Remember, if I can knock this down to an x squared, then I can use factoring, quadratic formula, complete the square, whatever to figure it out. So I really only have to guess and check long enough to find one answer. Okay, so I'm just going to start diving in. I always use, actually let's use a fraction first. So I'm going to use 1/2. I'm going to pull it from this pile to see if it works. I got a 2, a -5, a -4, and a 3. So if I drop the 2, what is half of 2? Half of 2 is 1. So that gives me a -4. So do you see how this is going to be pretty? It's not going to give me scary fractions for an answer. So if it's going to be pretty, that means keep going. If it ever goes ugly, just stop. So what is half of -4? That's going to be a -2, which gives me -6. What is half of -6? Well, it's -3, and I got a 0. So I just figured out one of my solutions, or one of my zeros, is 1/2. So this tells me I'm looking for a total of 3 answers. I just found out that one of them is a half. So now I can break down what's left. So what does that mean? Remember that this is an x to the third. So I'm going to start filling in with x squareds. So this is a 2x squared minus a 4x minus 6 equals 0. And now I can divide everything by 2 just to make this a little bit easier to handle. So I've got 2x squared minus 4x minus 6 is 0. So divide everything by 2. And I'll get an x squared minus 2x minus 3 is 0. And that's factorable. So two numbers that multiply to -3 that add up to -2 are a -3 and a +1, which means your other two solutions are a 3 and a -1. So what did I do? This was not factorable, so I guessed and checked using information from here, and I just randomly grabbed 1/2. I didn't know if it was going to work or not. It happened to work. And since I found one solution, that dropped me down from an x to the third to an x squared. I divided everything by 2, and then I factored what was left, so I need 3 answers, and I've got 3 answers. So that's one. So let's do another one. This says x to the third minus 3x squared. So x to the third minus 3x squared. And again, I just did this one at the beginning with rational zeros theorem, so we're just going to do it again real quick. So numbers that multiply up to a 75. Rational zeros theorem says to try these numbers. So I'll get a 1, a 3, a 5, a 15, a 25, and a 75. So that's step 1. Well, really and truly, I didn't have to do that because this is factorable. So what's common on just your first two? Pull out an x squared. What's common on your last two? Pull out a 25. Tell me what is in parentheses and what is not in parentheses. And I'm going to give you a little trick. If this was the difference, meaning subtraction, of two squares, you would get x plus 5x minus 5. Well, I'm going to change it up a little bit. Since it's the sum of two squares, I'm going to pretend for a second that it's the difference of two squares. And now I can just slap an I on here. Okay, so if it's the sum of two squares, you can factor it by x plus 5i and x minus 5i. So how many solutions am I looking for? I'm looking for 3. How many did I find? That's a 3. That's a -5i. And that's a +5i. So you have 3 solutions. All right, so let's get a couple more done. Let's do one that's more exciting. All right, x to the 4th minus 5x to the 3rd. Hang on. X to the 4th minus 5x to the 3rd plus 5x squared. plus 5x minus 6. Okay, so this is, I'm going to find 4 answers. My instructions are to use rational zeros theorem to kind of sort of narrow down the field. This isn't factorable as it stands, at least using an easy way. So what numbers am I going to try? I'm going to take 6 over 1, and those are where I'm going to pull from. So numbers that multiply to 6 are going to be 1, 2, 3, and 6, and all of that is over 1, which doesn't change what it is. So if it's going to cross in a pretty place, it's going to be in this pile. I need 4 answers. So if I get it down, if I find one answer and what's left is factorable, I can factor it. Okay. Worst case is I'm going to have to guess and check and find 2 answers, and it'll knock it down to an x squared, which I can manhandle all day long. All right, so I'm just going to try 1. And we may be guessing and checking for a bit. So I've got a 1, a negative 5, a 5, a 5, and a negative 6. So that's what I am trying. So I have 1. 1 times 1 is 1, which gives me negative 4. 1 times negative 4 is negative 4, which gives me 1. 1 times 1 is 1, which gives me a 6. And 1 times 6 is 6, which gives me a 0. Okay, so you just found out that 1 is one of the solutions. There are 3 more out there. I've got to find them. This is not factorable. So this is my x to the 3rd. I have an x to the 4th on this row. This is an x to the 3rd. Okay, so I'm going to go ahead and just start trying again and pull out what's there. So I'm going to try a 2, and I'm going to pull it out of this row. Since it ends in a 0, I can pull it out of here. So here's a 1, a negative 4, a 1, and a 6. So here's 1. 1 times 2, or 2 times 1, is 2, which gives me a negative 2. 2 times negative 2 is going to be a negative 4, which is going to give me a negative 3. And holy cow, 2 times negative 3 is negative 6, which gives me a 0. So I guessed and checked again and got another solution. So this is an x to the 4th. This is an x to the 3rd, which means this must be x squared. So x squared minus 2x minus 3 factors down to x minus 3, x plus 1, which means my other 2 solutions are a positive 3 and a negative 1. So rational zeros theorem gave me a starting place, and then I just used synthetic division to figure out what was left and to keep knocking it down. And so, there you go, sorry. I'll let you get caught up on that one. So those are your answers. So that gives you some place to jump off, holy cow, some places to jump off of. The next video, I'm going to do Descartes' rule of signs, and I'm going to do intermediate value theorem.